Good afternoon, everyone. Welcome to the International Hybrid Conference on July 12 to 13, 2024, organized by Universitas Mulia and the Global Technopreneur Campus. We are excited to have you join us for Exintisa and Seminastica, a prestigious event that brings together researchers and practitioners from around the globe to discuss the latest advancements in science and technology. My name is Gardika Pramudia Stefanus, and together with my colleague Valeriana Lukitusari, we are from the Department of Mathematics at the S.Pd Nopember Institute of Technology, Surabaya, Indonesia. Today, we will be presenting our research on pricing strategies using design of experiment in online and offline supply chain. We are excited to share our findings with you and look forward to an engaging and insightful discussion. Thank you for joining us today. In today's ever-evolving business landscape, the importance of understanding and managing pricing methods across online and offline supply chains is increasing. Our study focuses on the significance of pricing strategies in current business discussions by exploring situations where producers utilize both channels to meet diverse customer demands. By employing response surface methodology, we identify the most effective price levels for each channel and highlight significant demand dynamics, particularly in enhancing the profitability of offline channels. These findings offer practical guidance for decision-makers in optimizing business outcomes in complex supply chain environments. E-commerce is surging in Indonesia, ranking 10th globally in growth, with a whopping 78% increase. Source: kominfo.go.id. Many companies are now using both online and offline channels, known as a dual-channel strategy, to boost sales and manage demand fluctuations. However, this approach brings challenges like conflicts between channels and competition for market share. To succeed, companies need to balance both channels effectively. Despite the rise of online shopping, physical stores still offer better shopping experiences and social interactions. So, companies must find ways to make the most of both channels to make customers happy and maximize profits. The diagram illustrates the interaction between online and offline facilities in a dual-channel supply chain, focusing on pricing and demand dynamics. The objective of our study is to analyze the price effects of online and offline systems through experimental design. Using a price sensitivity analysis, we'll assess customer behavior regarding price sensitivity, including online (eta-O) and retailer (eta-A) price sensitivity, as well as cross-sensitivity from online to retailer (gamma-OA) and retailer to online (gamma-A). Data will be collected through surveys, targeting over 100 individuals aged 15 to 17, and the Central Composite Design (CCD) will guide our experimentation. Through analysis of purchase intentions and empirical modeling, we'll formulate price functions and cross-price sensitivities. Statistical significance will be confirmed using Design Expert v.13 software and ANOVA tests, aiming for R-squared values exceeding 70%. In our study, we executed an experiment by distributing a questionnaire and observing profit estimates as the response variable. We used the Central Composite Design to study two key analysis factors. The results of the experiment were analyzed using Design Expert v.13 software, where we transformed the free variables into codes based on rotation values displayed in Table 1. Based on interviews with business owners, we established that offline prices range between 16,000 rupiah and 22,000 rupiah, while online prices range from 20,000 rupiah to 26,000 rupiah. The results of these pricing ranges are presented in Table 2. We then confirmed our regression model using ANOVA and R-squared tests. The validation model showed strong statistical significance in the ANOVA test, with R-squared values exceeding 70%, as shown in Table 3. Central composite designs are selected due to their popularity and effectiveness for second-order response surfaces. These designs are known for their versatility and numerous, desirable features, particularly in terms of alphabetic optimality criteria and routability. Here, we present the polynomial regression equations used to generate the response variable from the results. NH notation used is as follows. Beta is ith constant. PRO is online price in rupiah. PR is offline price in rupiah. Beta O is price sensitivity on online line. Beta R is price sensitivity on offline line. Gamma OR is cross sensitivities of the line from online line to offline. Gamma RO is cross sensitivities of the line from offline line to online. Regression results show that higher offline prices significantly reduce demand, while online pricing also affects offline demand as customers shift from online to offline channels, as visualized in Figure 2. Higher offline prices lower online price sensitivity, increasing online demand, whereas higher online prices decrease demand due to increased sensitivity. These shifts are illustrated in Figure 3 using contour models. Based on the regression equation gamma OR, there is a significant change in demand sensitivity from online to offline markets as retail prices rise, as shown in Figure 4. The regression equation gamma RO indicates that an increase in offline prices leads to a shift in demand from offline to online channels. This shift is illustrated through the conversion of regression equations into contour models in Figure 5. From the analysis of the sensitivity of each line's beta O and beta R values, as well as the cross-line effects of gamma OR and gamma RO, estimated demand for each line can be derived. This pertains to online platforms, where demand shifts are plausible, potentially leading to increased demand for specific lines. Notably, the impact of store price adjustments on offline line profit margins, as depicted in Figure 6, is relatively insignificant. However, price increases on each line generally result in decreased profitability according to the regression analysis. Pricing strategies for offline lines exhibit a significant cross-price effect, while a reduction in demand for online lines constitutes a substantial factor. To elucidate the regression model further, a contour model is provided in Figure 7. Figure 8 displays the optimized results of the nonlinear regression equation. Online routes are priced at 26,000 rupiah, and offline routes at 22,000 rupiah, with corresponding demands of 23.2508 and 119.197 respectively. This configuration leads to 111.157 requests shifting from online to offline, and 21,9096 requests moving from offline to online. Our study shows how important different factors are for both online and offline systems, stressing the need for a balanced approach. While online channels should consider many factors, like price sensitivity, offline channels should focus on making more money. Most participants preferred offline options. We found that focusing only on profit in online channels could make customers less interested. So, online managers need to be careful with prices. However, our study had limits, like only including a certain age group and assuming everyone was healthy. In conclusion, online managers should think about what prices their customers will like to make more money and keep customers interested. Our study draws support from a range of scholarly and industry sources, covering topics such as dual-channel supply chains, customer satisfaction, and retail management. Through this diverse range of references, we ensure the reliability and credibility of our research findings. Thank you to all the participants who have attended and contributed to this conference. The success of this event would not have been possible without the participation and support of each and every one of you. May the discussions and insights shared during this conference serve as a foundation for further understanding in this field. We sincerely appreciate the time and energy you have devoted. Hopefully, we can meet again in future opportunities. Thank you.